Hi, welcome to the dynamics tutorials. So in this problem, we have a mass here at A connected through a pulley to a mass at B. The mass at B is 10 kilograms and it's just free hanging. The mass at A is 5 kilograms and it's resting on a frictional surface. So the system is released from rest. The coefficient of kinetic friction for A is 0.1, and we want to find out what the speed of B is after 1 second. So our first step is to create an equation for the length of the rope. So we have SA, which is the length of the rope going from the pulley out to the mass at A. We have SB, which is the length of the rope going from the pulley out to the mass at B. So length is equal to SA plus SB. This length of rope is constant, it never changes. And so when we take a time derivative of that, we get 0 is equal to the time derivative of SA plus the time derivative of SB. Taking a second derivative with respect to time, we get 0 is equal to d d squared SA dt squared plus d squared SB dt squared. Remember that the double dot means it's that second derivative with respect to time. Plugging in here, we've got the SA. If SA was to increase, then A would be moving in the negative x direction. If SB was to increase, B would be moving down. And so we can substitute in here that VA is equal to negative SA and VB is equal to negative VB. Likewise, the acceleration at A is equal to the negative of SA, and the acceleration at B is equal to the negative of SB double dot. Plugging this in, we get that the acceleration at A is equal to then the negative of the acceleration at B. We can then divide this up into two free body diagrams. So looking at the free body diagram for A, we can do sum of forces in the Y. A is not moving in the Y direction, so this sum of forces is 0, and we can calculate that normal force. We can then do sum of forces in the X. Now A is moving though in the X, so we have to say that that's equal to the mass times the acceleration of the center of gravity of A in the X direction. So in the X direction we have the tension, and then we have the frictional force. The frictional force is just going to be the coefficient of friction times the normal force. And that's got to be equal to our mass of 5 kilograms times the acceleration of the center of gravity at A. Then our second free body diagram, we have the mass here at B, so we have the tension acting up and we have the weight acting down. Sum of forces in Y is equal to mass times acceleration of B in the Y direction. So we get tension minus the weight is equal to 10 times acceleration of B in the Y direction. We need to relate these two equations back together. And so when we go up here, we've got this relationship. So we can solve this equation here for T and then plug that in to where we have T here. And then where we wind up with having A, the acceleration of A and the X, we'll substitute in the negative of the acceleration of B in the Y direction. We can then solve this equation and get that the acceleration of B in the Y direction is negative 6.2 meters per second squared. We don't need it, but if we wanted to, we could solve for the tension and get that that's 36 newtons. And then we have a constant acceleration. It doesn't depend on time. And so we can use the integrated equation that VB is equal to the initial velocity of B plus the acceleration of B times time. Plug that in and get negative 6.21 meters per second. Whoops, made a mistake on my unit here. For the velocity of B after 1 second. Thanks for watching.